This is another example from the text, and it has there's two parts which I will record, which I'll put in two different recordings. The textbook problem is from Chapter 1, Problem 79. And first I will do Part A. The problem reads as indicated here. A 40-pound bag of peat moss has these dimensions in inches, and a 40-pound container of topsoil, a different substance, has a volume of 1.9 gallons. I'm supposed to use this information to calculate both of their densities in grams per milliliter. And grams per milliliter is kind of a standard unit. It's not an SI unit, but it's a standard unit that we use in chemistry to express a lot of densities. And incidentally, in those units, water has a density of 1 gram per milliliter. So as we get the answers, we can compare to the density of water. First of all, I note the definition of the density. The density is mass divided by volume. So doing this problem is going to be one of separately calculating mass and volume in the appropriate units, and then applying this formula, mass divided by volume. So first of all, I want to do the first thing I'm going to do, as always in these, is write down the relevant equivalence relations. And in this case, they are all just sort of standard standard unit conversion equalities. So 1 pound is 453 grams. I know that because I see, I know I need that because I see I have a mass of pounds up here of 40 pounds. And similarly for the topsoil, I have a mass of 40 pounds, and I'm going to need to get the units in grams per milliliter. It's obvious I'm going to need a mass in grams. The other thing I'm going to need is notice that I notice that the dimensions of this container are given in inches. And I'm going to want to turn those into metric units, centimeters. And one that I didn't write down, and one that everybody should know, is this one. A cubic centimeter is the same thing as a milliliter. So that conversion will also be used. So if you can see where we're going here, we're going to convert the inches into centimeters to get a volume in cubic centimeters, and then we just simply equate that to milliliters. And finally, for the topsoil, the volume is given in gallons rather than in dimensions, and I can look up how to convert gallons into milliliters, and I find the conversion factor indicated here. So first we do the peat moss. We'll lower this so we can see these conversion factors. So the peat moss, I'm just going to calculate the volume, first of all, using the dimensions given. 14 inches by 20 inches by 30 inches. I multiply those three together, and I get 840 cubic inches. I convert this to milliliters in the following manner. I use the 2.54 centimeters equals 1 inch in this conversion factor. And of course that has to be cubed, and I use 1 cubic centimeter equals 1 milliliter. In that conversion, I see that the units cancel appropriately, and I get 1.37 times 10 to the 5th milliliters. The next step of the problem is to get the mass in the appropriate units. And for that, I'm going to use this conversion factor here. 1 gallon equals 3,785 milliliters. Oh, excuse me. I'm going to use this conversion factor. 1 pound equals 453 grams. And I put it in that direction, and the 1 pound in the denominator, the grams in the numerator, to get the units to cancel appropriately. And what I have when I do that, pounds cancels, and I get this answer, 1.8144 times 10 to the 4th grams. And finally, the last step in this is I calculate the density, and the density is mass over volume, and in the appropriate units I have the mass in grams, which I wanted, the volume in milliliters goes here, and carrying it out and showing 3 significant figures for the answer, I have 0.132 grams per milliliter. Notice that the peat moss is very light. It's about 13% of the density of water. In this part of the problem, I'm also supposed to calculate the density of topsoil in the same units in order to compare. And so, again, I want the volume in milliliters. And here I was given the volume. I was given the volume instead of dimensions. I was given it in gallons, and I used the conversion given on the previous page. That's right here, and so the gallons goes in the denominator to cancel. Carrying out that calculation, 1.9 times 3,785 gives me 7.15 times 10 to the 3rd milliliters. The mass is 40 pounds, just like the mass given for the peat moss, and that has the same value, and I will recalculate that. That's 1.8144 times 10 to the 4th grams. The density is the quotient of these. The density is mass divided by volume in the appropriate units, and carrying out that calculation gives me 2.52 grams per milliliter, and into 3 significant figures. And since the density of peat moss was 0.13, the conclusion for this is soil is much more dense than peat moss.